Hello everyone. Today we're going to be going through these two multiple choice questions from Chemistry Paper 1 from 2025. So let's start with question 1. So which species is produced at the cathode during the electrolysis of an aqueous copper sulfate solution using platinum electrodes? So I always find it helps to draw these questions out. So if we have a beaker here filled with water, and then we are going to have two electrodes, and then a battery up here as well, connecting them. So the cathode, let's call it this one here, and the anode is over here. So we have aqueous copper sulfate. So copper sulfate, when it dissolves in solution, it dissolves into its two ions, so Cu2+, and then also SO4-. So now we have these two ions that are in the solution. Now, at the cathode is negative in electrolysis reactions. So because we have a negative charge here, a positive charge here, these positively charged copper ions that'll be in solution, they're going to be attracted to the negative side because opposite charges attract. So Cu2+ is going to be attracted to the negative side. So if we have that negative side and the Cu ions are gaining electrons, that is where the reduction is going to be happening. So because reduction is happening at the cathode, copper is gaining electrons. But there's also water in the solution. Because it's an aqueous solution, we also have water involved in some of the reactions. So water has a neutral overall charge. H2O is neutral. But it can also be reduced. So if we go to the formula book and we look at this table here, so we're going to look for copper. We have copper being reduced. So we have, looking at this one here. So Cu2+ plus 2 electrons has a electrode potential of positive 0.34. And now we're also going to look for water. So water is here. 2H2O plus 2 electrons has negative 0.13. So because this copper reduction has a more positive electrode potential, that means that it is the species that will be preferred to be reduced because it is lower in the reactivity series. So therefore, the copper will be a species that will be reduced. So Cu2+ will become Cu neutral charge. So therefore the answer for question 1 is A. Question 2, we're looking for a tertiary haloalkane. So for this one, I drew them all out, all the different haloalkanes here. We have 2,2-dibromobutane, and that's A, and then B is 2,3,3-tribromobutane, and so on. So what we're looking for is we're looking for a bromine that is attached to a carbon that is attached to 3 other carbons. So if we have a look at this one, if we look at A, we have a bromine here, and then the carbon that the bromine's attached to is only attached to 2 other carbons. So it's not A. That's a secondary. But if we're looking at tertiary, the carbon needs to be attached to 3. So if we look at B, so we have this carbon or this carbon, they both have bromine, but they're each only attached to 2 other carbons, so it's another secondary. If we look at C, the bromine is here, and then the carbon's here, and then this carbon is attached to 3 other carbons. So our answer is C, because it is a tertiary haloalkane. All right.